Hi guys, I'm Jessica Salmon from Stony Brook Swim and Dive, and today I would like to take you guys on our experiment tour of the Shinnecock Bay and the open ocean. And today we will be collecting our data samples, and we'll just run you guys through it.
Yeah, so we're going to be looking at photosynthesis versus respiration. So how we're doing that, we all know that oxygen is produced during photosynthesis and consumed during respiration. But when a plant photosynthesizes, it's respiring at the same time. So you can't just look at oxygen, because oxygen production is actually photosynthesis and respiration. So you need something to subtract the respiration out of there.
So how do we do that?
How do you think we're going to do these with this?
The dark bottle doesn't allow for photosynthesis because there's no light, so any change in oxygen in that bottle will all be due to respiration. And in the light bottle, any change in there could be photosynthesis or respiration, so you can subtract the differences and find
Exactly.
the oxygen.
So how we're going to do that is by taking, we have a DO, a dissolved oxygen meter, and we're going to take readings right when you get them up from the water, and then we're going to stick these back at the marine station and allow them to do their thing for 24 hours. Then we're going to come back and take DO readings from both the light and dark bottles, and then use that to make your calculations for the lab.
While we're measuring for photosynthesis and respiration rates to see how much phytoplankton and zooplankton are in the water column. And these are like the foundation species for larger fish and whales. This is Quinn, my classmate, and this is the Niskin bottle. And basically what we have to do first is to trigger the top of the bottle to put it on the, the pin there. So we have that triggered, so it's open. And then the next step is to, oh my lord, this is, yeah, okay, yeah. So then we have the bottom open, like that. So then, oh lord. Then we have it open, so when we put in the water can come through, and then we take the sample at the depth that we want. And the things we have to make sure of is that the top is tight, so the water doesn't flow out when we close it, and the spigot is pulled out on the bottom. Oh.
Okay, Niskin team, get ready. Let's get it right above.
Yeah. Okay.
I'll hold it and you.
Thank you.
Touch it.
Don't drop it.
Don't drop it. That would be so bad. Ready? Down slow.
This is 2.
2.
This is 3.
This is 3.
So once, stop it.
Once this gets to the surface.
Stop it. Stop it.
Stop! There. 1. Ha ha ha. Jess. I got 1. Okay, so this is our DO meter. And right now we're trying to find water for it, like not seawater, to calibrate it. And after we do that, we can put it into our samples, and it will measure the amount of dissolved oxygen in each sample, and then we're just gonna note it down. Marine science, marine biology interests me the most because I really want to go into conservation work and researching different things about human impact as well, and how we're affecting these environments that are stable on their own. Thank you guys for watching. I hope you learned something about marine science today, and it sparks a little interest in environmental issues around our local waters. And I hope you guys look more into what SOMAS as a undergrad school is doing in research.